Hi, everybody. Welcome to Working with Secondary Indexes in YugabyteDB. I'm Karthik Ranganathan, one of the co-founders and the CTO at Yugabyte, and I'm going to tell you all about what kind of secondary index features does Yugabyte support. All right, so quick recap. What is YugabyteDB? Yugabyte is a transactional high-performance database that is ideal for building planet-scale cloud services. It brings together NoSQL and SQL into a single database that's built in a cloud-native fashion. Okay, so Yugabyte introduces secondary indexes into the NoSQL side, and SQL RDBMSs, of course, have secondary indexes. So how does secondary indexes work in a scale-out database? Well, Yugabyte builds its secondary indexes on top of its distributed transactions. We have a separate talk explaining how distributed transactions work, so would totally encourage you folks to check that one out. Distributed transactions in Yugabyte are fully decentralized scale-out architecture, and they have no single point of failure. If you want to scale out the distributed transactions and get more transactions, just add more nodes to the cluster. Okay, so let's take an example, right? Working through secondary indexes is much easier with an example. The example is one of a user profile. It's a very, very common application that you would have interacted with in most modern day apps. Let's say there's a table which has user ID as the primary key, right? Now, you could sign up in various services or log in with your email, but if you want to allow people to change their email, then it's ideal not to make email the primary key in a table. So in this table, we have user ID as the primary key, which is the first column. We have a first name, last name, and an email column. Now, users may not remember their ID and may want to enter their email, so we're going to figure out how to retrieve the data by the email address. Okay, so that brings us to the usage pattern, which is I want to find the user ID given the email. Now, this is ideally what a secondary index does. It speeds up access by some other column. So in this case, all we need to do is build an index on email. And the system, the YugabyteDB internally creates an index table where the primary key is the email and it has all the other pieces of info. Now, it primarily just requires the user ID to be present because it could always look up the first name and last name from the primary table. But if you want your lookups to be much faster, you can optionally include extra columns in your index table, which is what we have done. All right, so Yugabyte also supports the ability to put constraints on this index to say, I want only unique emails to be entered. I don't want a single user to sign up with multiple emails, so I don't want duplicate emails in my table. It supports that. But we're just going to go ahead with the simple example of allowing duplicates. Okay, so let's go right into the demo. I just opened up, we have a well-written blog that walks you through the entire scenario. So let's go right there. I'm going to open the same page. Okay, so here's the blog that is a write-up on exactly how the user profile example works and so on and so forth. We're going to go straight to trying this out. What I have on my command prompt, what I have on my command prompt is a simple installation of YugabyteDB on a single node. I'm going to go ahead and connect to CQLSH. Let's then create a key space for this app. We're going to create a table. The table has a user ID column, which is a primary key, a first name, last name, and email. And we're going to enable transactions on the scale-out table. Okay, so the next thing that we're going to do is to create an index on this table. Okay, if you take a look at what we just did here, we said create an index named users by email on the users table, specifically build the index on the email column, but also include the first name and last name so that my lookups are very efficient. All right, with that, we're going to insert some sample values, each of whom has a user ID 1, 2, 3, 4, 5, a first name, a last name, and an email. Okay, so if you just wanted to retrieve the details given a user ID, that's pretty simple to do. We said select star from users where user ID is 1, and it gives you the details of that user. Now, if you wanted to do the same thing but retrieve the same person's record via the email, then all you need to do is say select star from users where email equals, and just type in the email, and it retrieves the same value back, right? Now, and this is just a simple application of secondary indexes. It's an extremely powerful and useful feature. Now, what happens on updates, I think, would be the other question. So let's say we go ahead and update one of these records. So here, let's say we're going to find the user whose email is superman@yb.com. Okay. The next thing we do here is we're going to update that email from superman@yb.com to superman-new@yb.com. Okay. All right. So now that we've done that, the original query should no longer work. So if I say select star from the app where the user has an email superman@yb.com, it would return nothing because we updated the index. Whereas you would be able to select the user whose email is superman-new@yb.com. Okay, so the consistency of data is automatically maintained for you by the secondary index feature in YugabyteDB. Okay, so let's continue further. Okay, so we talked about the utility of the feature. Let's quickly talk about performance. So we've done good at-scale performance testing of secondary indexes in Yugabyte, and here's a quick overview. A lot more details are in that blog, so please feel free to read the blog for all the details. As a setup, we created a 3-node YugabyteDB cluster with 16 vCPUs, or 16 cores. We set up the database to have a replication factor of 3. And we created an index on the value column, the user email column, just the way we had done in our sample application. And we keep looking up the data by the value. So this is a key value example. We keep looking up by value to retrieve the key, which is exactly similar to looking up the user ID given the email. Now, we wrote about 100 million keys. It took us about 3 hours to load the data. And we were getting about over 8,000 write operations per second at a 12 millisecond latency, right? And you see the graphs below which show you that the latency and the operations per second are pretty steady. And if you want to scale out, you just have to add more nodes. Now on the read side, we read 1 billion keys through their values, and it took us about 3 hours to do so. And we were getting about 80,000 read operations per second at 250 microsecond latency, so it's really, really fast reads. And once again, as the graphs below show, both the number of IOPS as well as the latency are pretty constant. Finally, you can try this out yourself. There's the blog, there's our quick start guide. You can install Yugabyte on your laptop and you can get started. Thank you for watching.